Microservices have become a popular architectural style for building cloud applications, resilient, highly scalable, which can be deployed independently and evolve rapidly. However, it requires a different approach to designing and building applications. Communication between microservices has to be efficient and robust. With a large number of microservices interacting to perform a single business activity, this can be a challenge. There are two basic messaging patterns that microservices can use to communicate with other microservices. We have synchronous communication and asynchronous communication. Synchronous communication. Here, one microservice calls an API that another service exposes using an HTTP or gRPC protocol. This option is a synchronous messaging pattern because the caller, that is, the first microservice, waits for the receiver's response. This results in a temporal coupling between microservice 1 and microservice 2. And if we want the system to have high scalability, this type of communication would not be suitable. Imagine if we have several microservices involved and connected synchronously. An overload would occur, and this would likely affect the availability of the entire application. Then, to solve that, asynchronous communication comes in, which is based on events or messages. Here, a microservice sends a request without needing to wait for the response, and one or more microservices process the message asynchronously. That is, a microservice that sends or publishes a message or an event, and there are one or several microservices subscribe to that publication to perform some operation. All of this happens under the control of an event broker, also known as a message broker, which is responsible for receiving messages or events and then distributing them to different consumers. In this way, we could have many microservices receiving events in a decoupled manner, giving microservices autonomy. Events are delivered almost in real time, so consumers can respond immediately to events when they occur. Producers, who are the ones sending the event, are completely decoupled from the consumers. A producer, that is, the microservice that sends the event, does not know which consumers are listening. The consumers, that is, those who receive the event, are also disconnected from each other, and each consumer sees all the events to which it has previously subscribed. This would be the ideal type of communication for a microservices architecture. For asynchronous communication, we have here some technologies that can be used. We have Kafka, Azure Service Bus, Amazon SQS, RabbitMQ, and Azure Event Grid.
We cover this type of solution in detail in my course, where we build a complete microservices architecture from scratch using .NET, Azure, and Terraform. Check it out. The link is in the description.